Hello everyone, I'm Pravlika. In this video, I'm going to explain my analysis on human genome data. Here, the first screenshot shows about my successful completion of monsoon workshop. While coming to the human genome data implementation, I have detected the number of scaffolds which are of 607. I have also calculated the longest scaffold. I have calculated the average length of a scaffold, which is of 5.36 million base pairs. I have also calculated the number of occurrences of nucleotide pairs which are of ACGT. I have also calculated the time taken for counting each of these characters in the sequence of genome. The time taken for counting the occurrence of A is around 34.83 seconds. Time taken for counting the occurrence of G is of 30.72 seconds. While coming to the time taken for occurrence of C is of 29.76 seconds. While coming to the occurrence of for counting the occurrence of T, the time taken is of 31.27 seconds. The count character function took in time complexity of big O of n, where n is the length of genome. The time complexity says that that the time taken to count each of the occurrences is directly proportional to the length of the genome. I have also replaced all the characters of n in the genome sequence. I have also calculated the content of 80, which is of 58.76 percentage. While coming to the approach used in my human genome data, I have created several modular functions for reading the genome data, for replacing the characters, as well as for generating genome statistics, and for calculating 80 percentage to efficiently process and get the accurate results. I have used all these functions. I have also calculated time complexity, which I use to optimize the algorithm and to make it more readable. While coming to the implementation of my code, this is my header file where I have all the necessary headers required for the implementation of human genome. I have used several functions such as void reading genome data, get character count, and replacing n with a, determining 80 percentage, and generate genome statistics. All these declarations are present in my header file. While coming to the definitions of the function, I have used a reading genome data function, which efficiently reads the genome file line by line. It records the length of the scaffold and returns the longest scaffold which is present. It takes the entire genome file as a string and calculates the and reads the whole genome file and calculates the longest scaffold present. While coming to the replacing n with a, it takes the whole genome sequence as a string and replaces all the characters of n with a in the genome sequence. While coming to get character count function, it takes the genome sequence as well as a desired character whose occurrence to be counted, and it returns the occurrence of the total occurrences of the desired character. While coming to the generate genome statistics, it takes the number of scaffolds as input, largest scaffold and maximum scaffold size as its inputs, and it returns the overall length of the scaffolds and calculates the average length of the scaffold as well as finds the longest scaffold. While coming to determining 80 percentage function, it calculates, it takes a genome sequence and counts the number of occurrences of A, and number of occurrences of T, and it gives the occurrence of A and T in percentage. While coming to our main implementation, we have based on the input given by the user, we can implement several functions such as enumerate, substitute, as well as a stat analysis, and 80 ratio. If the user has for instance, if the user has given an input of enumerate, it calculates the number of occurrences of the desired character, which are of ACGT. While if the user has entered substitute, it gives the it replaces all the characters of N with A. If the user has entered 80 ratio, it calculates the percentage of 80 content present in the human genome data. While implementing this code, I have gone through several challenges. One of the main challenges is processing of the large data files. To process these large data files, I have optimized my read data function by processing line by line. I have also increased the readability of my code by using several modular functions for reading the data. For counting the occurrences of uh, each character, the count character file count character works on big O and time complexity, which represents that the time taken to count the occurrence is directly proportional to the length of the genome. By using several functions, I have increased the readability of my code. Thank you for giving me this opportunity.